So in your notebooks, you should have this already glued in, and if not, you should glue it in after the lesson. So we're doing things a little bit out of sequence just because I'm not going to be here for the second day in a row. So it says here, factoring a difference of squares. So right now we have just been common factoring, which is good. So remember, factoring means I want brackets in our answer. It's the opposite of expanding. So I have 3 examples here, and we're going to practice expanding. And remember, we use the acronym FOIL to help us out. So we're going to look for any patterns that we can see here with these 3 examples. So my first term, I multiply my first terms together, x times x, which gives me x squared. I multiply my outside terms together, x times -3 gives me -3x. I multiply my inside terms together, positive 3x, and I multiply my last terms together in each bracket, -9. So what happens here again, we have like terms in the middle. So I can write my final answer as x squared. Well, this is a -3 because I always have to look in front. -3 plus 3 gives me 0. So I don't actually write anything. And then I carry down this -9. So that's like saying 0x, and we don't write whenever there's a 0. It just means that it's gone away. So I have that example there. This next one here, if I take FOIL, and again, you can kind of practice that on your own. It says here, x times x gives me x squared. X times +1 gives me +1x. 2 times x gives me +2x. 2 times 1 gives me +2. What I do next here, again, I look for any like terms, and I do have them. They are in the middle here. And I write out my next answer, which is x squared plus 3x plus 2. So remember, we don't add the exponents whenever we add. The only time we add those exponents is if we multiply. Okay, the next one here that we're going to do, again, I have a binomial times a binomial. See if you can try that one out on your own. I'm going to multiply the first 2 terms together. X times x gives me x squared. I'm going to multiply the outside terms together. X times +9x gives me +9x. Sorry, x times +9 gives me 9x. Then I multiply my inside terms. -9 times x gives me -9x. And then I multiply the last terms together, which gives me -81. I can collect like terms here, which gives me x squared. My like terms here are +9x and -9x. When I simplify that, +9 minus 9 gives me 0. So again, I don't write that. I'm left with -81. Okay, so I've chosen these 3 examples here to see if you can notice anything. So my hope here is that you're going to notice that these 2 answers only have 2 terms, whereas this middle solution has 3 terms. So we're eventually going to be looking at the middle case today, but we're going to focus on the outer cases here, so 2 terms. Now remember, my whole goal here, so this is what I've just done is expand. When I factor, what does that mean? That means I look at this answer and I have to get that as an answer. I would have to look at this and get that. This and then get that. So we're going to look at the simple case here. So how is it that we get 2 terms? Well, if I look really closely at the question here, oh, I didn't mean to do that. If I look really closely at the question here, do you notice anything that is similar about this question and this question? X plus 3, x minus 3 for one question. That gave me 2 terms as a final answer. And then I have x minus 9, x plus 9. That gave me two terms. And then even if I look here, x plus 2, x plus 1. So these two questions that I've highlighted here have something in common versus that middle equation. Now, hopefully you are looking at that and you are saying, well, in each of these cases, I have a plus 3 and a minus 3. Those are the same numbers, just different signs. Here, I have a minus 9 and a plus 9. Same number, just opposite signs. When that happens, when we have the same number with opposite signs, we will always, whenever we expand, we will always get two terms. And our final answer. Why? Because one term will be positive and one term will be negative, and that will give me 0. One term will be positive, one term will be negative, which will give me 0. So that's what we're going to focus on today is this case here. So I have a couple steps that you have written out on yours. That's called a difference of squares. So this method only applies when the question is a binomial, which is two terms. 1 and 2. Both terms are perfect squares. We're going to talk about perfect squares in a moment. Perfect squares are basically when you can use your square root function or your square root button on your calculator. And the binomial has a subtraction sign. So it has to have a subtraction sign. There has to be only two terms, and you have to be able to take the square root of the terms. Okay, so step number 1 here. This is my first question, x squared minus 25. Step 1 says take the square root of the first term. Okay, this piece here is something new, but hopefully you'll be able to catch on. When I take the square root of that, that means I'm going to share the x's. The square root of x is just, the square root of x squared is just x. I take the square root of the second term. The square root of 25 gives me 5. We're not going to include the negative sign when you look at that. They will always be negative, but we're going to take the square root of both of those numbers there. So what do? Place a plus and minus sign in one in each bracket. So I'm going to have two brackets as my final answer. I take the first square root, which is x, and I put it first. I'm going to put a plus sign, a minus sign, and then the square root of the last term, 5 and 5. Does it matter what comes first, plus 5 or minus 5? Absolutely not. All that matters is that you take the square root of the first term, you take the square root of the second term, and you place both of those answers in the same. So this is almost the same binomial, except for the signs have changed. Okay, so we're going to go over a couple more examples like this, and hopefully you can catch on. Okay, the next one here, I have two terms, and I can take the square root of both of those terms. So when I take the square root of a squared, it just becomes a. When I take the square root of 16, I can put that into your calculator. You can put that into your calculator. You get 4. So my final answer here will be bracket. I have two sets of brackets. Take the square root of the first term, which is a, and I place it in both brackets. And then I'm going to write one plus sign, one minus sign, and then I write 4 in the last one there. That's how we factor a difference of squares. Okay, the next one here, a little bit more trickier, but we still can do the same thing. Here I have two terms. There's a minus sign in the middle, and I can take the square root of both of those terms. So again, you want to use your square root button. Your square root button looks like that check mark that's on the board there. So now I'm going to take the square root of this first term. Well, I can't type in 25a squared in my calculator, but I can type in 25 and find the square root of that. The square root of 25 gives me 5. There's also a variable here, so I still have to take the square root of that variable, which is just a. The next one, again, I'm going to take the square root of this. The square root of 16 is 4, and the square root of b squared is just b. So my final answer here will be two brackets. In my first bracket, I write 5a first, 5a first, a plus sign, a minus sign, then 4b, 4b. Okay, and that's it. Okay, I'm going to do the next one here. So again, I can take the square root of the first term. I can take the square root of the last term. If I take the square root of the first term, so I'm going to give you 10 seconds. See what you get when you take the square root of both of those answers, or those pieces. Okay, hopefully when you took the square root of 25, you got 5, and there's an x squared there, so I just write x. I take the square root of 36, which just gives me 6, and then y squared, when I take the square root of that, that just gives me y. So I can write out in 2 brackets 5x, 5x, a plus sign, a minus sign, 6y, 6y. Okay, the next question here, again, I have 2 terms. There's a minus sign in between them. And what do I need to do? I can take the square root of them. So I'm going to take the square root of the first term, take the square root of the last term, see what you get for a final answer. I'd like you to actually try this to see if you're kind of on the right track instead of just copying it out if that's what you're doing. Okay, hopefully when you took the square root of 4, you got 2. And when we take the square root of x squared, we get x. When I take the square root of 9, I get 3. So your answer should look something like this, 2 brackets. The first piece that goes in is 2x plus minus 3, 3. I'm hoping that you were able to get that. And again, if you have any difficulties, you can always ask a friend to help you out once the lesson is over. Okay, this next one here, it says remember to common factor first. Okay, why do I have that up here? So the first thing I want you to notice here is that I have 2 terms in that equation. I have a 5 and I have a 20. When I have a 5 and when I have a 20, that's 2 terms with a minus sign. So you really, really want to use difference of squares because that's the criteria. You need 2 terms with a minus sign in the middle. But the problem is if you were to type in the square root of 5, you get a decimal. Just like the square root of 20, you get a decimal. So I can't use a difference of squares, but it really, 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 really looks like a difference of squares. So when that happens, when you find a difference of squares that looks like 1 but isn't quite 1, we can common factor first. So again, here from yesterday, 5 is my lowest common factor, or is my lowest number. So again, I'm just going to go off to the side here. So my factors of 5 are just 1 and 5. I start at the top. Does 20 divide in by 5? Yes. So 5 is my greatest common factor. What does that mean? I divide by 5, divide by 5. On my next step here, I will write my greatest common factor, which is 5, and then write the answer when I divide everything. 5 divided by 5 gives me 1x squared, minus 20 divided by 5 gives me 4. Okay, so now I've common factored out, and if you look, I can take the square root now, because this is 2 terms. I can take the square root out of that one, and I can take the square root of that and still get a whole number. When I take the square root of 1x squared, I get 1x. When I take the square root of 2, I get just 2. So my final answer here, when I write it out, I have to include this 5 because I factored it out, and then I'm going to write 2 brackets. Okay, so my first piece here, I put 1x, a plus sign, a minus sign, and then just 2 and 2. So that's common factoring with a difference of squares, which is what we are going to expect from you to do. Okay, the next one here, again, I have two terms with a minus sign in the middle. I can't take the square root of 2, I can't take the square root of 50, so I'm going to look to common factor. So I start with my smallest number, which is 2. My common factors are 1 and 2. So I'm going to see, does 50 divide by 2? 50 divided by 2, type that into your calculator, and you get 25. So 2 is my greatest common factor, which means I divide everything by 2. And on my next line, I write equals 2, first bracket, second bracket. Okay. Oh, no. Sorry, there's no second bracket. There's just one bracket. Got a little ahead of myself. Okay, when I common factor out here, I go 2 divided by 2, which gives me 1, minus 50 divided by 2, which gives me 25a squared. Okay, the next step here is I want to take the square root of each of those terms, which I can. The square root of 1 just gives me 1. The square root of 25a squared just gives me 5a. So on my next line, I will write here, I keep that 2. Then it's bracket, now 2 brackets. I put my 1, put a plus sign, put a minus sign, and then I put 5a, 5a. Okay, and the last one, which is probably about the trickiest difference of square example that you would possibly get here, is 5b squared a minus 45a cubed. So again, I have two terms. I have a minus sign in the middle, but I can't take the square root of 5 or 45. If you were to try that, you would get a decimal, and in difference of squares, we cannot get decimals. So what do? I have to common factor out. So I start with my lowest number, which is 5, and I think of my factors of 5. 1 and 5. I start with my highest, 5. Does 5 divide evenly into 45? Yes, it does. So 5 is my greatest common factor. Now there's one other piece we have to be careful of. Both of these terms have an a. So actually my greatest common factor is 5. What's my lowest exponent? 1. So I just write 5a. So on the bottom piece here, I'm going to divide both terms by 5a. Okay, so on my next line, I write my greatest common factor, which is 5, bracket. 5 divided by 5 gives me 1. I'm still going to have the b squared here because b squared, there's no b on the bottom, so that stays the same. I have an a1 here, an a1 here. That cancels out, so I'm left with no a's. Subtract. 45 divided by 5 gives me 9. A cubed divided by a just gives me a squared. Okay, so now I have two terms. Now I have a minus sign, and now I can take the square root of both of those terms. So the square root of 1b squared just gives me b. The square root of 9a squared gives me 3a. So on my final answer here, I'm going to write is equal to 5a bracket. I have two brackets, b plus minus 3A, 3A. Okay, I know it's difficult because I'm not here, but I am going to ask that you try and do this. And if you need help, again, you have very, very smart friends among the class. So if you can try and ask each other for help and help each other out, that would be wonderful. Okay, so make sure you use your time wisely today. And if you finish your difference of squares worksheet, I would like you to finish the factoring work yesterday if you did not finish that.